Alright, so today in video 1 we are going to fill in the example and the diagram box of your properties of water. You are going to do the sentence using the vocabulary word for homework. Sometimes I give you an example, sometimes I give you a picture, sometimes I give you neither, but we will talk about some options here. We know that water is one of the most common substances on Earth. Its unique properties impact the roles it plays on the Earth. It is the only substance that can be found in nature as a solid, liquid, or gas. Think about the polar ice caps, think about the flowing rivers and streams and oceans, and then think about water vapor in the atmosphere. Water is rarely pure. It contains minerals, pollutants, other gases, such as in the atmosphere. It contains water vapor, nitrogen, oxygen, carbon dioxide in river water and salt water and other kinds of fresh water. There's also those same dissolved gases of oxygen and carbon dioxide for the animals with gills to be able to carry out respiration. Water is important to all civilization. It does vary based on geography and climate, and we know that in history humans built civilizations around where they could find water because it's so necessary for life. The ocean does make up the majority of the water on the earth, and we know that it's salty because as the earth formed and it rained, the earth's crust was washed into the sea, and many of these substances and chemicals that were washed into the ocean were dissolved, salts. The salinity in the ocean does vary. It's very salty near the equator where it's the hottest and there's the most evaporation of water. Also in the deepest parts of the ocean where it's extremely cold, cold water is more dense, and so and it's more salty, and so there is also near rivers and where they dump into the ocean, it would be the least dense. But on average, the salinity averages 35 parts per thousand. Buoyancy is our first definition, and it's related to density. Buoyancy is the upward force that keeps objects afloat. When you think about you laying on your back and floating in a pool or floating in the ocean, your weight is distributed over a great amount of space, and therefore the buoyancy is greater than your weight. If your weight becomes greater than the buoyancy, then you will sink. So think about balling up in a ball. If you change from stretched out, floating on your back, to balled in a ball, you will sink. Polarity is responsible for many of the properties of water, including how attractive it is to other molecules. Water is H2O. It has 2 positively charged hydrogen atoms and 1 negatively charged oxygen atom that is actually got 2 electrons. So you can see there's an equal number of positive and negative. However, the hydrogen atoms are smaller, so the charge is not quite distributed evenly, but it does give oxygen many of its unique properties, including cohesion and adhesion and surface tension, and we're going to talk about all those in a minute. Water molecules are attracted to other water molecules. They're also attracted to other polar molecules, and these polar substances many times will dissolve in water, and that's why water is known as the universal solvent. So these molecules are hydrophilic if they love to dissolve in water, and hydrophobic if they don't. Now, I've already given you a diagram for polarity. I have not given you an example, but I'm going to pause here and show you a video, and that's where we're going to see our polarity example ideas. All right, surface tension is water's attractiveness to each other at the surface. Molecules will bead together. They're sticky molecules. That positive negative attraction makes them sticky. And we see this is if I drop a penny in with its surface area like this into a cup of water, it's going to splash very quickly. However, if I slice it in the water by flipping it the other way and reducing its surface area, I can pile a lot of pennies in a cup of water, and I'll show you an example of that in a minute. I'm also going to show you the example of the water strider, and the Jesus Christ lizard. The water strider is an insect that, due to the shape of its feet, it can appear to run across water, as can the Jesus Christ lizard. They both appear to walk on water, and it's due to the shape of their feet and the fact that they barely dent the surface and the water closes back up very quickly. So we'll pause here and watch the video. The next term, you have this in your notes from when we were studying measurement. We know that density is just a ratio. We know that water has a density of 1 gram per cubic centimeter, so it's compared to many things that can sink and float in water. If they float, their density is less than 1. If they sink, their density is more than 1. And so I want you to think about what diagram you could use to illustrate density. Maybe a density column with a ball floating on the top and a brick sitting on the bottom. I don't know, but give you a second to think about what you might put for your diagram. So here's an example, this picture, and obviously it's been a little engineered and magnified, but you can see the surface tension from the swimmer, the way he is floating, so buoyancy and density are at work there, and then he's got this bubble of water around him because he is barely breaking the surface as he moves. The next property of water is adhesion. And adhesion is the ability of water to stick to other substances. Glass loves to stick to water. If you have ever had a sweating glass on a hot summer day and all this condensation on the outside, you might notice that when you pick it up off the table or off the coaster sticks, and you pick up the coaster and the glass, and you have to pull the seal or break the seal where it has adhered to water. So that might be the picture you want to draw to go with your example. Water also has the unique ability to defy gravity and climb uphill. And if it didn't have this property, then how in the world would plants get watered? Because it doesn't rain often enough to get all the plants all the water they need. So they need to be able to take water up through their roots and send them to their stem and leaves. And that is the property of capillary action. And you can draw that image, or I'm going to stop and show you a video clip here that will give you an idea for capillary action. The next property is cohesion, and co means pair or together. We're co-chairs, we're both doing it. And so in cohesion, we're talking about water sticking to water. So it's got to be two of the same. And in one of the activities you're going to do in the Magic Molecule Lab, and some of you will get to it today and some of you tomorrow, is you're going to see how many drops of water you can pile on a penny. So the first layer of water droplets will be sticking to the penny, and that will be adhesion. And then as you add more, the water droplets will be sticking to themselves, and that will be cohesion. So you might want to use that image for your diagram, or you might want to think of another image where water sticks together. Water's cohesive properties give it its surface tension. We mentioned at the beginning that water is often called the universal solvent because it dissolves so many substances. All of the things that are hydrophilic and love water dissolve very easily. So sugar dissolves in hot water, coffee dissolves in hot water, tea dissolves in hot water, salt dissolves in hot water. Hot water can hold more, warmer water can hold more than colder. Colder, the solution becomes very saturated. And then we have substances that don't dissolve in water. They are not solvent. What does the dissolving is called the solute. What is dissolved into is called the solvent. So water is the solvent. And you can think you can either use my example to draw a picture, or you can come up with another picture idea. Water has another unique property, and that's its specific heat. Water has an unusually high boiling point for liquids that have similar weights and densities. It also has the unique fact that it heats and cools very slowly, so it takes longer to heat water up. It takes longer to cool water down, which is why you can go to the beach in October and the air temperature may only be in the 70s, but the water is still the same temperature it was in July. You can go to the beach in early June and the air temperature may be in the 90s, but the water temperature is still cool. It might be still in the 50s because water has not warmed up. It takes an incredible amount of heat to raise 1 degree, 1 gram of water 1 degree. And if you think about the best example I can give you of something with high specific heat and low specific heat is if I put water in a metal pot and I sent that metal stainless steel pot on my stove and I put my hand against the pot after 1 minute, I'm going to get burned because that stainless steel has a very low specific heat. It conducts heat very well. Water, however, I could probably put my fingers in the top of the water and it would not even be really warm yet. It hasn't reached boiling point, hasn't reached a temperature that would burn me because water has a very high specific heat. This is why in the summer, again in early June, it's 90-some degrees outside, the sand may be burning your feet, but the water might still be cool because the sand, you've got just as much sand right there on the beach as you do water right there where you're going swimming, but yet the sand has gotten very hot because its specific heat is lower. So water's polarity, the arrangement of its positive and negative charge and the hydrogen molecules being smaller and the oxygen molecule being larger, give water all of these many unique properties. Another thing to think about with water is imagine that you are sitting in a hot tub. It's got full of liquid water. The steam is rising as gas off the water and clouding up your mirror. And you have a cold drink sitting on the edge of the tub filled with ice. And very few other substances could you observe all 3 states of matter at one time. Another interesting thing about water is in the solid state, it is actually less dense. So ice has a density of only 0.99 grams per cubic centimeter because the particles are packed tightly together, and that usually means it's going to be more dense, but in the case of water, it's less dense. So all about water is unique. It kind of defies some of the things we think about other substances, but it gives it lots of unique properties.